good morning, good afternoon, and good evening to some of you, depending on where you are in the world. Welcome to the second session of the 2024 IIoT World Manufacturing Days event, Beyond Silos, Streamlining Data Flow with a Unified Namespace, sponsored today by HiByte, HiveMQ, and EMQ Technologies. My name is Hamish McKenzie. I'm your moderator for this session, joining not from Munich, as I usually would be, but from the French Riviera, as I am currently on vacation. Yes, that is how committed I am to the world's best IIoT event series. And so, despite competing offers from the Cannes Film Festival, which is taking place just down the road as we speak, here I am. I've also managed to pick up a cold on my travels, so hopefully my voice is going to hold out. And it won't spoil your enjoyment of the event too much. So, let's find out what we're going to be talking about in this session. We're going to be diving into the essentials of unified namespace, its unique advantages, and how it outperforms traditional systems by ensuring real-time operational visibility. Our guest panelists are going to look at some of the implementation challenges, evaluate UNS's integration with SCADA systems. We're going to look at how UNS revolutionizes manufacturing operations, enhancing efficiency and connectivity across a digital ecosystem. And finally, our guests are going to be sharing some insights on measuring the ROI of these kind of digital projects. So we've got an awful lot to cover. I'm very keen to introduce you to our guest panelists today as well. But before I do that, just a little bit of housekeeping. Please feel free to drop your name and location into the chat. Just helps us get a feel for who's there, because we can't see you. The session is going to last just shy of an hour, as I'm sure most of you are aware. I'm going to introduce the panelists. We're going to be getting lots of insights from them, but of course, we're going to also leave some time at the end for the most important people in the room. That's you, our audience, because we want to get to as many of your questions as we possibly can. So I would ask you to please put your questions in the Q&A tool in the platform. Don't use the chat. It just makes my life a lot easier if I can see them in the Q&A function, and it's also more likely that you'll get your question answered that way as well. So please use the Q&A function for your questions. Don't wait till the end. Start putting them in as soon as you like. As soon as something pops into your head, then get your question in there. And I'm delighted to say that it's now time for me to introduce you to our panelists. We've got 4 today. First up, we have Ravi Srimamanyan, who's Director of Industry Solutions Manufacturing at HiveMQ. Ravi is a product management leader with extensive experience delivering high-quality products and services that have generated revenues and cost savings of over 10 billion for companies like Motorola, GE, Bosch, and Weir. He's worked across many different industries, including mining, oil and gas, industrial automation, automotive, mobile devices. Literally, we don't have time to go through the entire list. We'd be here till the end of the session. He's incredibly experienced. He is in charge for HiveMQ of evangelizing, enabling sales of the HiveMQ solution amongst manufacturing, energy, logistics, and industrial automation customers. And he's a very experienced presenter. He presents online, in person, all over the world. And that's why we're very lucky to have him here with us again today. Welcome, Ravi.
Thank you.
Next, we have John Harrington, Chief Product Officer at HiByte. John is focused on product management, customer and partner success, and company strategy. His areas of responsibility include market research, customer use cases, product priorities, go-to-market, and financial planning. So he's got an awful lot on his plate. He's very passionate about delivering technology that improves productivity and safety in manufacturing in industrial environments. And he spent his 25-year career delivering software to manufacturers, but also working at manufacturers in operational roles. So he knows both sides of the coin. And that's given him a unique perspective on how suppliers and end users play their own integral role in implementing these kind of new technology solutions. He has an MBA from Babson and a Bachelor of Science in Mechanical Engineering from Worcester Polytechnic Institute. Great to have you with us again, John.
Thank you, Hamish. Looking forward to the conversation.
Fantastic. Next up, we have Ernest Russell, who is Technical Content Manager at EMQ Technologies. Ernest brings over a decade of experience in information technology and broadcast engineering, supporting some of the largest media companies in the world, including CNN, Turner, and Fox. He's always been passionate about learning and writing, and he earned a master's degree in networking and telecom management. As a technical content manager at EMQ, Ernest is focused on knowledge sharing and best practices for MQTT and IoT. Thank you very much for joining us, Ernest.
Thank you.
And next up, we have Brent Wassel, who's Principal IT Business Analyst at McNeilus Truck and Manufacturing. Brent's a highly experienced information technology engineer within the industrial automation industry. He specializes in IT-OT convergence and architecting production systems with secure integration into business networks. So he's skilled in Allen Bradley, Rockwell, Ignition, HP products, Wonderware, Cisco systems. Again, the list is almost endless. He's a very successful operations professional with a bachelor's degree focused on mechanical engineering from the University of Minnesota Twin Cities. Welcome, Brent.
Thank you. Happy to be here.
Fantastic. And finally, a few words about me, your moderator. Again, my name is Hamish McKenzie. I'm a former IDC analyst, and I've been running my consulting, coaching, advisory, and consulting practice from Munich in Germany since 2006. I work with software CEOs and executives in Europe and North America, helping them with their growth efficiency, set strategy, refining their positioning, that kind of stuff. And I also work as a coach and sparring partner, walking alongside CEOs and other senior executives, helping them improve their leadership capabilities as well. If you want to know more about me, find me on LinkedIn. I think I'm the only Hamish McKenzie in Munich, so it shouldn't be too difficult to find me. Final reminder, please get your questions in the Q&A function in the tool, and please get them in as soon as you like. Don't wait till the end. Please keep them as short as possible as well, and it would be ideal if you can also tell us which particular panelist you'd like to answer that question, or if it's open to all of them, then that's also fine as well. All right, so that's all the housekeeping started with in the introductions. Let's get into this, and I want to start really at the beginning, I guess, and talk a little bit about what a unified namespace is and why it's important. So I wondered if we can start with you, John. Can you describe the essential components of a unified namespace for us?
Yeah, so thanks, Hamish. When we think about a unified namespace, functionally, it's very simple. It's a single place that people within the organization can go to get access to the latest manufacturing-based information. Mm-hmm. So, any sort of information that you need, whether it's order information, whether it's historical information, whether it's telemetry information, whether it's execution information, you can go and get access to that. What that requires is, number one, we need some sort of a system to aggregate that data, to be able to collect data or provide access to data from telemetry, from historical, transactional, master data files, that kind of thing. We also need to standardize that data, because in many cases it wasn't put in place for the use cases that these people are trying to solve. So we need to standardize, organize, and contextualize the information so that we can easily find it. And what we often find is that that's done through using the ISA 95's hierarchical organization. So company, site, asset, area, line, sometimes you have zones, cells, you name it. So really just kind of hierarchically organizing that information so that different business users can go in and get access to that. The key is that it needs to be self-service. So the real value is that users are able to self-service, get access to, subscribe to the information that they need. And it's also that the data was set up for different use cases. So we may have the operations team that needs process data, but we may have like the quality team that needs quality information on a cell. We may have the operations management team that needs access to what's the OE on a line, or we may also be storing things like various regulatory reporting or energy reporting, that kind of thing. So the key with this whole solution is that we can put all this information together. We can provide access to it to our employees. The way that we're typically implementing this is using an MQTT broker. And that's why, we're going to talk with Ravi, we're going to talk with Ernest, because MQTT provides this really powerful ability to, within one broker, organize the information into a hierarchical topic namespace, and then people can very easily subscribe to the data that they need. And MQTT is a protocol. It's very flexible. It's very efficient. It's very scalable. So we're able to put all this information together and then provide access to it. So it's really just about providing that one holistic access point that people within the company can get access to data that they need to do their jobs.
So I did a lot of work with ERP companies in the past, and we always used to talk about single version of the truth. Is that basically what you're saying in terms of this data? It's the version where
think of it more as, instead of a single version, because essentially we're pulling data from other systems.
Okay.
So by definition, it's not a single version, but it's a single access to the truth.
Single access point. Okay.
So that way you go to one place, you get access to it. And, really what's driving this is that people are able to really provide broad-based access to information, which is completely new to most companies, given our historical system. So you talk about ERP, typically, very few people had access to the data. They could go in and see it in forms, they could get reports, but it was always very slow. And then you had the MES system, and you had all these different systems, and really now people can pull that data out of those transactional systems that we don't want to change, but then can have free access to pull it into things like Power BI, or pull it into their CMMS system, or pull it into an analytic in the cloud, and just have such a rich access to the data. So that's where we're really seeing the value is, yes, the ERP system is still in place, the MES is still in place, but this provides the access to that data that's never been flexibly had in the past. You always had, also like you may have an HMI on a machine, but a lot of times the engineer wishes they could just pull that data off into a spreadsheet and run some calculations on it, or pull it off into another system. And this provides that really easy access to that data, and the agility of, every time you put in more data sets into your UNS, not only is it available for the user that you put it in for, but it's available to everyone in that organization. So it's very easy to kind of put different information sets in there, and then people to be able to query across those different sets or get access and work with that data.
Okay, and so what are some of the other things that a UNS can enable you to achieve that perhaps aren't possible with other architectural patterns?
Yeah, it's really just that flexibility. It's that I can go in, I can see information from, it could be the factory schedule, or the area's schedule, to the OEE, to the power consumption, to the telemetry, and I can get that data, I can pull it out, and I can work with that. And it's, companies refer to it, and I'm sure that Brent will talk deeply about how he's using it, but we hear companies say that this is like revolutionizing their operational landscape, because it's that flexibility. Mm-hmm. Today, I need this data, and tomorrow I need different data because as business changes, as the factory changes, as, inventory didn't come in, or the efficiency goes down, we need to look at data, we need to respond to data, and we need to make changes. And it's just that flexibility that people have never had with their traditional systems. And then you can actually roll this out across the entire enterprise, so that, for people at corporate who are doing analysis and who are trying to get access to data, it makes it even easier to get access to that data. So really, really powerful to leverage a lot of these new tools.
All right, fantastic. So I think that gives us a really good context. And as you mentioned, we want to get stuck into some, to some real world examples, how people are using it. I wanted to move over to Ravi now, so he can talk a little bit about, at perhaps also a relatively high level, what are the kind of use cases that we're looking at when we're talking about unified namespaces, and what industries in particular are maybe the ones who are really driving this.
Yeah, thank you, Hamish, and that's a very important question, and thank you, John, for setting the stage on what UNS is and why it's important, and then putting a plug for the MQTT broker and how MQTT is very suitable for setting up UNS, right? So one of the ways to think about UNS, and this is very interesting, because when I talk to people about UNS, they're like, hey, is it like the Windows Explorer, right? The way you kind of like explored different levels of like file systems within a Windows Explorer on a Windows system. And I say yes and no, right? Because in a Windows system, there is a particular way to organize the file, which is basically 7 levels down or 5 levels down, and that's the only way you can access that file. Whereas in a unified namespace, there's many ways to do it. Obviously, using the physical location, that's one way to do it, but also using the logical way to look at data. For example, right? John mentioned overall equipment efficiency, and which is very, very important within manufacturing, right? So we have a medical devices manufacturing company that wants to calculate the overall equipment efficiency, which is a key performance indicator for them to measure the performance of their manufacturing machines. And the way they do it is like they are using what we call a functional namespace, which is a namespace that allows your data to be organized by the kind of functions that are performed. For example, all the production data coming in from all the production systems are in one namespace. All the maintenance data is in a different namespace. So to be able to calculate the OE, you need like the functional, you need the maintenance data, you need the production data all to come together. And so this namespace allows you to easily bring it together so that you can then figure out, like, identify machines that are underperforming, take steps to be efficient and be productive, right? So instead of you having to create a science project of figuring out where all your data is to be able to calculate the OE of the different machines, this automatically provides a way to organize the data and gives you the most recent data and the most contextualized data for you to be able to do that. So that's one example. And of course, it's this medical device manufacturing company, but there's like the use cases are endless for an OE from an OE perspective. John actually did mention energy tracking or energy usage, right? So we have another customer, which is a automotive tier 1 manufacturing customer that wants to be able to measure the energy across all of the different factory locations, right? And they want to do that through an energy tracking application. And this tracking application needs like specific data to be able to do that. And this is done through like an information namespace where the data is organized based on the information content provided, right? So in this case, for example, they need like all the temperature parameters or the pressure parameters or some other parameters to come together. And so the information namespace is used to organize all of this data so that this energy tracking application can easily track or bring all this data together to be able to track the energy, the electrical usage across the different levels within the factory, slice it and dice it different ways. So management can take a look at from a higher level, and people that are more on the operation level can look at it in a more detailed level, if you will, so that they can identify patterns and trends in the electrical usage and figure out like how to reduce it. Or if there is any issues that happen based on this, they can start like planning for that, right? So that's the second example. The third example that I'm going to provide you with is a pharma manufacturing company. Again, regulatory compliance is a big issue, and one of our customers actually use us to be able to create like a unified namespace to bring all the regulatory data. The other use case is like helping them figure out like how their high valued equipments are performing, and they use like what we call a definitional namespace to be able to do that. That basically organizes data based on the definitions and attributes. And so in this case, it is a bioreactor that they're really interested in being able to like bring together. So there is a namespace for the bioreactor that brings all of the definitional data related to that, like so that they can see the latest alarms, alerts, and other data points in one location. They can compare and contrast the different bioreactors in operation to see how efficient they are. These bioreactors are mobile, so they can actually go into different sections within the factory to see in this section how it's performing, in this section how it's performing. So they can actually compare the same bioreactor as it performs in different locations. So they use like this definitional namespace. So these are some of the like higher level examples of using like a definition namespace. And just real quick, like an MQTT broker, for example, right? One of the reasons why it is used in like in a unified namespace is the fact that it can do like federation of data, right? Because like in a lot of cases, like say like a beverage manufacturing plant that has different systems, different locations, they might want to set up like a unified namespace across different factory locations, maybe even within the subsystems within the factory. But they also want to be able to do that at a more higher level, at an enterprise level, right? So the MQTT broker, by virtue of how it performs, is able to bring in the federated data to like higher levels, so that like there can be consolidation at different levels. So it's easy for them to see how the data is performing, or how it's like the factory is performing at a production level, at a machine level, at an enterprise level, so that they can compare and contrast. So these are some of the examples that we see of unified namespace, Hamish.
Okay, fantastic. And I think that last point is interesting in terms of where I want to go next, which is to talk to Brent to get his end user perspective. So because you're talking about things, being able to look at all these different elements simultaneously. And one of the biggest buzzwords, if you like, that always comes up whenever we're talking about these kind of data related issues is real time and how these systems and solutions can help businesses make better real time decisions. So I wanted to ask you, Brent, how does, from your perspective, as an end user company, a unified namespace enhance that real-time aspect of decision making within manufacturing operations?
Yeah, thank you. Great question there. It's all about data. We've talked about data, that word, a lot, and we think about the landscape of manufacturing, and we have a ton of data. But data by itself isn't necessarily useful. We have to turn that data into usable information. Mm-hmm. So how quickly can we take data and turn it into something that we can action on? And when you talk about real-time information, that's an absolute key component of everything. We need to understand the current state of the business in real time. If you have kind of legacy operations or you don't have things connected, you can't understand the current state of the business. So how are you able to action on things? If you have machines or systems that have issues or have alerts, but you're not listening to that, or it's not able to easily be consumed, how can you action on it? We'll talk later on predictive maintenance and that type of thing, but that all ties in for the access to kind of the real-time information. The unified namespace, as we've talked about, by definition, it's a structure and it's the events of everything. And so if you want to make those real-time decisions, having a single spot to go to consume that information and making it easy to share. I think a common theme that's going to come up a lot today through this discussion in particular is how easy we can make it to share data, share information, and kind of that time to value. Ravi had a really good point on kind of the architectures and how it can tier. So having a site UNS or even functional areas, so you can say this has all the information about this particular line or this particular process information, but we want to make that available for other consumers. And with the architecture and leveraging MQTT brokers, they're designed to tier. So we can take our information from different areas or different sites and kind of aggregate that up to a central level so we can truly understand the state of the business.
Okay, and you mentioned predictive maintenance there, which I know is one of the most important use cases. It's a huge, a huge deal in terms of, avoiding downtime, saving costs, et cetera, et cetera. So can you maybe talk about the role of the unified namespace in particular in relation to predictive maintenance?
Yeah, absolutely. I think high level, just kind of on predictive maintenance and what that is, there's a lot of different ways in how that can work, but in general, to overly simplify, for predictive maintenance, you need to build a baseline for normal operations, and then you need to have a real-time value that you're comparing against that model so you can do deviation detection and anomaly detection. So this is how my machine or my motor or my process normally runs. We have a model for that and we can detect deviations. So having said that, there's a lot of ways to kind of do that. A lot of different vendor type solutions, they have what I call the black box approach, where we connect to your devices and your sensors, and then we send the data up to a cloud system and we provide some insights and value on it. And that's not bad, that's good. That provides value and that solves a business problem on it. But the problem is when you look at scaling, or what happens when somebody else also needs that exact same information. Do you then do another discrete integration to say, hey, we also need information from those devices? And this totally different system over here, they also need information from that. And before you know it, you have 6 different functional groups with different discrete integrations with their own tools, all talking to the same thing. When you can flip that architecture and say, I'm a machine, I'm a sensor, I have information, here's everything I have, I'm going to publish that for consumption to a UNS. It makes the time to value significantly easier. For data scientists, for people who want to build models off data, the first question they're going to ask is, where is that data? How do I get to it? If you can point them to a spot and say, this is the real-time state of the business right here, you can build your models off of this, and that's also the real-time value. So once you have your model built and you're running it, you can tie into these tag points and run your models against those. And furthermore, when you have insights or results of, hey, we're predicting some anomalies on this or a failure, you can publish those results back into the namespace for consumption, which can be automatically consumed for like a maintenance system, for example. So you have deviations, it detects it, and then it publishes a result back, and now you have a ticket in your CMMS system automatically. Or you have alerts coming out on phones, or whatever system makes sense with it. It makes it very easy to that time to value. So I think that's a pretty specific example, but on predictive maintenance, which is a huge thing, it's how do we do that quickly, agilely, at scale, and make it a solution that we can replicate? And I think that's how the UNS structure helps with that significantly.
Right. Yeah, no, that's a great example. And you know, we're talking about because you mentioned integration a lot there, and obviously, in the modern manufacturing environment, we're talking about integrating a lot of different IoT devices, which are present in throughout the processes, right? So how does a UNS support that integration?
Yeah, for adding more devices, I think I tend to think of everything as producers or consumers, and it can a end thing can be a producer and a consumer of information. So you have PLCs, devices, sensors. Those are typically producers of information. They might also need to consume information. What batches am I running? Am I supposed to be doing this? What operations? What materials am I grabbing? There's a lot of producing and consuming kind of going back and forth. We talk about UNS and how that can facilitate the ease of integrating multiple devices in different systems. It decouples things and it gives everything a central spot to go to. And the example I just gave, instead of having generic black box system talk directly to device, it's I have a solution, I'm going to talk to the namespace. I'm going to use that as my broker to consume from and produce from. At very small scale, it might seem like extra work because it's, well, I have this thing and this thing, why don't I just make them talk? And you can do that. And that works. And I always say that at small scale, that's just fine. Do your discrete integrations, prove out that you can get what you want working, but then make it scalable. Make it flow through a UNS type architecture, because then you've unlocked scalability and you've also decoupled it so that if system A needs to be replaced or changed for whatever reason, as long as it can produce and consume from the same spot, then you can effectively change that end system. For IoT devices in particular, there's a lot of technologies that leverage that play in with a UNS architecture. So specifically, we talk like edge gateway devices. Sparkplug B is something that I think we should talk about as well. It's really, really good for devices to infrastructure. You have systems, and I'll give examples on this later, but you have a gateway that has a lot of information about a process. We simply plug it into the network and say, give it a little bit of context, a group ID, device ID, that type of thing, to say who you are and where you are, and you just publish your information and it shows up. And so it can really help having a structure, a spot to plug into, and then a way to easily say, I'm a new device, I'm a new system in your ecosystem, I'm a new application. Where do I go? What do I talk to? And having that common framework to plug things into helps significantly with scale.
Okay, fantastic. So scalability, flexibility, scalability, we're starting to really understand the power of this, from a much more three-dimensional perspective now. I think we should also address the fact that it's not, that there's very rarely a panacea right out there, right? So there's also certain times when using a UNS might be a disadvantage. There might be certain limitations in certain situations. So let's talk a little bit about that, John, to start with. I know there's some advantages of using UNS with SCADA, for example, but there are also some disadvantages. Maybe you can talk a little bit about those.
Yeah, no, it's a good question, Hamish. And at some level, I see, there are some limitations, but I think it's really where UNS is evolving into, because I think UNS is evolving. We're all learning. We have many customers who are implementing it. They're learning. We're learning as vendors. We're evolving the solution. So some of the limitations that we saw with UNS, one is when it's tightly coupled to MQTT. So MQTT is great. It's a publish and subscribe broker-based technology, but in some cases you don't want that in your integrations. In some cases, the users may not have MQTT clients, so they'd rather pull the data out of a database. Well, the UNS can still be used. We can just land the data in a database for them, or they can use a third-party tool to subscribe to that data and put it in a database. We also see that in some cases, data needs to be requested. For instance, if you want to know who the customer is on an order, you don't want to publish every single order that a company has ever had into the UNS. In some cases, you want to make that request and have that move back. And so there are some other protocols like REST that tend to be much more efficient at having that request response type of approach. There's also historical data that you may want to move your historian data up into the cloud. Well, moving that through an MQTT broker doesn't make a lot of sense. You may want to consume that and move that. So what we're seeing is the UNS is evolving into a multi-protocol and multi-component solution so that it can solve all of these needs. Because once we've got that connectivity to all these different systems, all these different sources of data, there are different request patterns, and we need to be able to solve them. So I don't see the UNS as a concept as going away. What I'm seeing is that the capabilities that people are looking for is expanding, and so the technology sets, the technologies that HiByte supports, the technologies that Hive supports, that EMQ supports, that others in the industry are supporting, is just expanding. And for instance, one thing that we're also seeing is people want to turn their data lakes or their data warehouses in the cloud into a UNS. Well, we can apply that same contextualization and organization of the data, and then we can push it up into, say, Snowflake or into Amazon's S3. And once that data is organized, then I still call those UNSs. It's just, it's that next step or that next layer. And so, we're just seeing a lot of evolution there and a lot of experimentation, a lot of really exciting opportunity there too.
Yeah, absolutely. And I wasn't suggesting at all that there was, serious challenges, which means that it will go away. I just meant that's the point I actually wanted to get to, was that this is not a static thing, right? It is evolving because, more than anything else, needs are evolving all the time as well, right?
Exactly.
But in the initial sense, if people are coming to this for the first time, then they may think, well, hang on a minute, I'm not sure this really fits my use case. But then it's important to realize that it really is evolving. All right.
Hamish, can I just add something real quick?
Sure.
John is absolutely right. I mean, there are a lot of use cases where an MQTT broker absolutely makes sense, because by definition, because of the publish subscribe, because of a lot of the hub and spoke model use cases that MQTT brings in, it's great. But I think unified namespace is a framework. It's the way you implement it completely depends on the use case that you're trying to drive. While the MQTT broker is very suitable, and we can obviously go over the details, I absolutely agree that there are other ways to do it as well. So there is no one size fits all, and that's the beauty of the unified namespace, that there is no single way to do it. It all depends on what your use case is, what you're trying to solve, just like other things. So.
All right, yeah, thanks for that, Ravi. I want to come to Ernest now, because one of the big problems, not just in this scenario, this context, is data volume. So in any digital market economy process, where the sheer volume of data is simply overwhelming, and that's one of the reasons why so many companies have yet to really extract maximum value from all the data they're producing. So Ernest, could you talk about, perhaps from your experience, in terms of what are some of the best ways to manage this huge volume of data more efficiently?
Sure. There's different components that are going to build this system that John mentioned. That I love that Brent brought up Spark Plug, right? And so part of it is the UNS, the unified namespace, and having a standard of storing data Another is MQTT, right? Being an efficient protocol in helping to transfer that data. And then actually Plug B lays on top of MQTT and helping to create a unified a unified way of those devices, those IoT devices, to connect and deliver data, right? But as Brent mentioned, you don't want to, you may not need that data every millisecond, right? And MQTT, it's real time, and with sub-second latency, we're getting this device data constantly, right? So we may not always need to say the temperature is 70. Ravi, the temperature is 70. John, temperature is 70. Temperature is 70. We may not need that every second. Right. And so one of the options that we have when we're building this type of UNS is we want to, one good practice is event-based architecture, right? And what that means is we're going to monitor and look for changes more than status, right? So now it's 70, it's 70, we know that, but when it gets to 80, we want something to happen, right? We want, when it gets to 85, we want to turn on a light. When it gets to 90, we want to maybe turn on a fan. And this is two-way communication, right? And even as far as being able to give not just status, but give commands to a device. So that's one way is you want to build it as an event-driven architecture. And secondly is we can strategically place our MQTT broker so that you have an edge broker, right, on site that's filtering data and only moving the data that you want into the cloud, right? Because that's where it becomes expensive, when you're moving data in and out of the cloud. But by having these edge brokers and then bringing that data up in a very organized and filtered way, you're able to make some sense out of that data.
Okay, fantastic. And it's interesting you mentioned the word expensive there. Now, I'm assuming, but correct me if I'm wrong, Brent, that because we wanted to talk a little bit about integrating legacy systems, and I'm imagining that could be one cause of expense is trying to do that, integrating legacy systems into unified namespace. Can you talk a little bit about those challenges?
Yeah, we run into that all the time. It's the greenfield stuff is always easier, right? We're building something brand new. What's the ideal architecture? What do we want it to look like? Greenfield's always easy. For existing stuff, though, it's kind of, there's a lot of old devices and old protocols and old stuff, especially in automation. You know, when I came into the industry, I always thought that manufacturing was very futuristic and advanced. Robots, lasers, flying machines, crazy stuff. And then you get into the industry and you find out that it's like, hey, there's some old stuff running on these old wire protocols, and there's data highway, there's just a bunch of old stuff. So it's okay, we have all this legacy stuff. We've been making product for a long time, whatever our manufacturing operations do. Now we have this brand new thing, and there's all this stuff people are talking about. There's these cloud systems, there's AI, there's a lot of cool things happening in technology. And it's like, I have no idea how to go from here to here. Mm-hmm. That's the landscape where we run into. And it's not as complicated, I think. Well, I'll just get to the answer on it. The answer is, for stuff that doesn't natively talk the protocols that you're using or plug into your UNS, you have to have some type of translator. Yeah. Typically, generically, I just refer to this as an edge gateway. Here's a specific example. I have some devices on my manufacturing floor, and they talk Modbus. How do I make those devices plug into my UNS device? Well, you need some type of edge gateway that can talk the native protocol of the thing. So what's the thing you want to connect into your system? What does it talk? You have to be able to communicate with that thing. And it could be all kinds of protocols. It could be something Modbus. It could be something over serial. It could be something very different, right? But you have to talk to the edge device where it's at, have some way to translate that, and then publish the results back. We do this a lot for integrations of new equipment, and it really hits on the time to value. I think that's a huge thing of why this architecture, why UNS is so big, is because it enables you to realize value quickly. Earlier, I talked about data. How do we turn that data into something we can actually use? How do we take information from a Modbus gateway on a machine on a manufacturing floor and turn that into something useful? John had mentioned earlier that it's not just the data, it's also adding some of the contextual awareness. If you've done kind of control systems down on the actual wire, the data, the things that the end device is talking might not make a lot of sense. By the time you get it into your UNS, you want to have some level of organization and contextualization on this. This could be you've modeled your data so that it fits a certain model, so that I now know, okay, this is an instance of a temperature and vibration sensor. Here's what the payload looks like. Now I have a model built. Now I have this organized. We have 50 other of these legacy devices in our architecture. We don't have to buy brand new equipment and replace it, which is very expensive. We just have to find a way to, can we make what we have talk and work? And that's a business decision. It's, you know, do we replace stuff or do we try to kind of enhance what we have? And that depends. We call that kind of the bolt-on IoT type solution, where we want to get this data for this process, but there's not sensors for it. What do? Do we look at replacing the whole machine or the process? Potentially, that could make business sense on it. Maybe it doesn't, and you just want to get some information like the predictive maintenance example. So you do what I call the bolt-on solution, where you add devices or add sensors to enhance the data coming from your end process, and then you organize it by the time it gets into your UNS. Did that kind of answer the question? Any comments on that, or anything I can clarify more? Anybody else have any feedback on that?
Yeah. So one thing, Brent, is that I think you mentioned about the sensors, right? And this is where I think UNS really scores, because once you're plugged into the UNS framework, adding new sensors or adding new subsystems is fairly straightforward, right? So, and again, starting small with this, what you need to do, and then adding more systems is the way to go, right, Brent?
Yes, absolutely. Yeah, starting small on that, solving specific use cases, and then scaling. I probably mentioned the word scalability, but that's huge, because we look at the problems we're facing today that we're trying to solve, and then we look towards what are the problems we're going to have in the future? What are the questions we're going to be asking a few years from now? A lot of what I talk about and what I present and what I try to architect is, how do we set ourselves up for future success? We look at, I would argue, the biggest buzzword, and you know, it changes in technology every year. It's what's the latest and biggest big thing? Is it AR, VR? Is it artificial intelligence right now? You can't look at anything anywhere without seeing AI this, AI that. Is it, you know, deep fakes, videos? Artificial intelligence is huge. How do we take that and apply it to manufacturing? I look at it and say, any generic system, application that's going to provide value, generically speaking, artificial intelligence, you're going to take inputs, you're going to do something, computations, predictions, whatever, and you're going to provide outputs, inputs and outputs, producers and consumers. How do you set yourself up for success with artificial intelligence in the future? It's being able to imagine, you say, what information do you need? Yep, we have it all. It's right here, and it's all organized, and it all has context for you. We make it very, very easy to consume that and provide value. That's what UNS significantly helps with.
And that's I don't know if you did that deliberately, but it's a perfect segue into what I wanted to talk to Ernest about now again, which is he has a lot of experience in terms of combining OT and IT when implementing UNS, and also in terms of how UNS helps facilitate exactly the kind of digital transformation that you're talking about, especially in terms of things like AI, digital twins. So Ernest, could you talk a little bit about those issues from a UNS perspective?
Sure. And when we talk to companies about digital transformation, one of the first questions I ask is, have you been able to combine your IT and operations departments? right? Are they communicating? Because essentially that's what we need to do, right? We need to connect those PLCs, those SCADA devices that were at some point recently very, very siloed, right? They might have been available to those local. Maybe you had to terminal in, bring your laptop and terminal into a device to get the logs, to get the operational data. But when you start to combine the operations and IT, that's really when you start to unlock the true potential of smart IIoT, or smart manufacturing, right? Is to be able to combine those devices. And as Brent mentioned, one of the biggest keys and facilitators of that is that edge node gateway, right? That knows how to talk to the actual physical device and knows how to talk MQTT, right? So it's local, doing that translation in a very lightweight way, right? And sometimes these are on devices as lightweight as maybe just a Raspberry Pi, right? But that knows how to talk to both sides and can bring that operations data into that IT world.
Okay, fantastic. So we're running at slightly shorter time now, and I want to make sure we get even more specific now in terms of real implementation issues, but also leave a few minutes at the end for some questions, because I know you guys have also been very helpful and already answered some of them, but we've still got some which we would like to get to if we possibly can. So I want to cover two things. Firstly, I want Ravi to talk to Ravi a little bit about how really getting practical. How do you get started with a unified namespace,
Yes.
and why is an MQTT broker most suited for the implementation? And then want to come in to let all of you speak a little bit about ROI on these kind of projects. So Ravi,
Yes.
if we can maybe just start with you, how do I get started if this all sounds great and exactly what I need? How do I get started?
Yeah, absolutely, right. So when it comes to UNS, the first thing people think about is like, hey, what tools are available? What solutions can help me figure out the UNS journey, right? But to me, it's like the journey starts even before the tooling, right? It's about people and process that need to be aligned to be able to get you on this UNS journey. I think the first thing is like, hey, what is the data governance that you want to do? What sort of like data do you want to bring under management, and what will really help you achieve what you want to do, right? So that is a complete process thing. You don't need any tooling for that, and it's completely associated with your company's culture and what you want to do and how you're organized. I think getting that in line, or at least getting that started off, is absolutely important, not just for UNS, but like for general management of data, right? Specifically for UNS, what I've seen customers do is like before they even getting started, right? I mean, they might have multiple factory locations. They just want to get organized on the topic structure, right? How do they, John briefly mentioned the ISA 95 model, but there is multiple ways to skin the cat. So if you have like different factory locations, what is the way that you want to see the data organized so that when all these different UNSs come together, they all look the same, right? You don't want individual factories to have their own ways to do it. You want to give them some flexibility, but at a higher level, you want to be able to govern this in a more succinct way, right? So that having that documented somewhere and managed, and if you have any modifications that need to be done, that is like managed by a governing body within the organization, is absolutely important. The third thing is like security, right? I mean, what sort of security methods that you want to do, whether it's like identity and access management or other security mechanisms, right? Just looking at that, how is that is going to be managed. And last but not least, just like the data encoding and the formatting of the data, Ernest and others mentioned like Sparkplug. If that is going to be used, how does that play into your topic name structure and your encoding of the data? If that is not the case, how are you going to manage that? What methods are you going to use to bring the data in a format that is useful for you and things like that? So these are the general considerations. And of course, a lot of tools are available. All of us can definitely help customers out, but these are the key things. The MQTT broker, what it provides is like it has a lot of these things already built into it. Like, for example, how the topic is organized, for example, how it's mapped to the namespace, how to do the security, for example. That's a big aspect of what the MQTT broker does. And by virtue of also supporting Sparkplug, you can actually bring in some encoding and formatting. So a lot of these things, and then we also talked about the broker federation, which is a key thing that MQTT brokers can provide. So all of these things lend itself to like ideally doing UNS. But like John mentioned, there are a lot of use cases where maybe you don't want to use a broker. You want to use other mechanisms to be able to do what you're trying to do based on your use case. Again, looking at what you want to do and trying to figure out like what the best way to do it. Organizing your data, organizing your processes is absolutely key for you to succeed. Okay,
fantastic. Thank you, Ravi. All right, so let's just finish off. Let's come to ROI, because at the end of the day, any of these type of projects need to deliver ROI if they're to be conducted at all, right? So if I can come to you first, John, from your perspective, how are you seeing companies measuring the ROI of digital projects? And then I want to ask Brent, but also obviously the other panelists, about their kind of also real world experience of how ROI is being delivered here. So John, how are you seeing companies measuring the ROI of these kind of projects?
Yeah, thanks, Hamish. And just to comment on Ravi's points, yeah. I think he kind of covered it in his first bullet, but I think it's even more important to think about what are the use cases of the people that are consuming this data going to be doing? And we often see where UNSs go wrong is when the focus is just on driving data in and not thinking about how it's going to be used.
Right.
Because as Brent had commented on earlier, it's critical to contextualize this data, and we need to put it in this standard platform. And in order to do that, we do that based on the use cases. So the use cases will land in different levels of the ISA 95, depending on if you're looking at metrics for the line versus if you're looking at asset maintenance data for the asset. Could be the same data point, but lands in two different places because it's used for two different use cases. And it's contextualized very differently. So I think looking at use cases is where we often tell people, you need to start, and then you need to do all that other stuff that Ravi had commented on, security and governance and whatnot, and technology to solve those problems. But so then, that falls into what's the ROI? Well, if people are focused on use cases, then the UNS becomes a key component to solving that use case, and ROI is often very easy to calculate. We're doing a predictive asset maintenance use case, and we're rolling this out across our company or across our facility. And this is the benefits of doing that, because we've determined that the focus is on machine uptime or online uptime, and this is the benefits. It tends to be really relatively easy. Where we find it's more challenging is when they say, well, we've got all these use cases, but we need to, what's the value of this infrastructure? And where we see people come down on that is, it's what's holding them back from implementing more use cases. And the biggest bottleneck in most of the manufacturing companies that we work with that's holding them back is the capacity of the OT and the IT team. These teams are heavily worked. They're doing a lot of different projects, and there are tons of projects that they could do that would add value to the business, but yet the tooling and the capabilities in place don't allow them to scale and don't allow them to easily maintain. In fact, as they implement more projects, they end up having to spend more time maintaining those projects than they do adding new ones. What the UNS provides is the ability to scale those teams without adding more people. So they're able to deploy these use cases much broader, much more scalable. I think we've all kind of commented on scalability, maintainability. That's the benefit of the UNS, because by providing that abstraction point, you can really solve multiple use cases by hooking up one new system and providing access to that data. So it's really powerful from a scalability of the OT and the IT team's capabilities, or so that they can address more projects. And that's where companies have really accelerated and been able to justify this, is that, in the past they could only deploy 3 projects, but next year they can deploy 60 because they're putting the UNS in place, and it's going to enable them to do a lot more faster.
Okay, fantastic. Brent, do you maybe have one more example in terms of ROI business benefits before I try and fit in one or two questions?
Yeah, just so real quick, I think when you talk ROI, you have hard savings and soft savings. I think the hard savings would be predictive maintenance opportunities. We predicted this. We were able to proactively do maintenance on this during an appropriate time. What is the cost of a couple hours of downtime on a critical machine? Depends on your process, but those are directly measurable. Then you have the soft benefits, which are how do you put value on being able to consume information in real time, understanding the state of the business. And that can be a tougher question to answer, I think. But what we've seen as we have these solutions and we implement them, once people realize the value of how easy it can be to consume data and turn that into information, they want more, they want everything. They don't understand why it hasn't always been this way, because that's what we're used to in our personal lives. We're used to having an iPhone. Everything we want is in our hands. Why should it be any different for business? If we want information, we should just have to know where to go to look for that and have it be available.
Right. Okay. Fantastic.
And that's when they talk about revolutionizing their operational environment, because it's just so much faster, right? And so much accessible. Yeah. Sorry, Kamish.
Yeah, no problem. No, it's an important point. So yeah, I realize we're running out of time, but I do want to just try and get to a couple of questions. And because we talked a little bit again about IIoT, although someone has now just answered that question, I see.
No, go ahead. Ask the question.
They basically wanted to know how can, in terms of that, making that IIoT integration work a bit better, or the partnering up between the teams. Have you got some tips on how that can be, that kind of partnering process can be improved? Maybe Ernest, maybe if you want to talk about that?
Yes, sure. One thing that is improving, and that I'm seeing from all the conferences, both in person and virtual, that I attend, is we technology anymore, right? Like we're using open source, right? And that's one of the ways as an industry we're moving in the right direction together. Using open source makes it easier to integrate and innovate new solutions as this evolves.
Okay.
Hamish, I think one thing that we're seeing is providing solutions that enable both IT and OT to work together. And I guess I see this a lot because the Hybrid Intelligence Hub provides that. The IT team can go in and define the structures of the data that they want and the connections to the target systems, while the OT team can use the same system to go in and connect to the source systems as the domain experts do the contextualization and kind of digital wiring of those data sets, and then it allows the two teams to collaborate within a common system. Also, like IT has a lot of business practices that they use, leveraging the cloud, leveraging containerization, leveraging Active Directory, things like that. So if OT solutions support that, then the two can work together. When you have OT on an island from IT, that's when they don't. So it's in our eyes, it's a lot about collaboration, both on the team perspective as well as on the technology perspective, that really creates a win-win. And IT's technology has just grown so much lately, and the potential with cloud and data lakes and data warehouses, it's incredible what can be done.
Thank you, John. Guys, I'm afraid we're out of time. I'm not surprised because this is such a rich subject, but I know you've all been very helpful in answering some of the questions in the chat anyway. If there are any questions which haven't been answered, we will get back to you and make sure we follow up on those answers after the session. It just remains for me to say thank you very much, guys, for your amazing insights, your knowledge, and thanks again to our sponsors, HiByte, HiveMQ, and the EMQ Technologies. Without you guys sponsoring these sessions, we wouldn't have all this great content to share. So thank you, audience, for listening in and for your great questions. And it's now time to move into the next session, which is navigating the data tsunami, the rise of IIoT sensors in Industry 4.0, sponsored by Influx Data. I'm hosting another 2 sessions today, so I'll hopefully see you later. And in the meantime, enjoy the rest of the event. Thank you very much, guys.